Hi, this is Zhenhao Yan.
And this is Zeqiu Zhang.
We're going to show our solution of the question 3. And I'm going to solve the first part, the first sub-question, and Zeqiu will solve the second part of question 3. So according to the sub-question of the sub-question 1, we know that it wants us to find an equation that can find the time at which the number of infected individuals in the population has reached its peak. So it means we need to differentiate the equation of I, and therefore this is our step of differentiating IT. And as you can see, the first, according to the equation of IT, the only the t is the only one that we are not knowing what it is. Other numbers such as b, c, and k are all commons, and I0. So I0 times 1 plus k to the power of b divided by b minus c is actually a common number. So we can just put it out of a bracket, and you can see on our second step of differentiating IT, we have a bracket that includes differentiation of the rest of the equation. And in order to differentiate the IT, we need to use the product rule. And first we differentiate 1 plus k times e to the b minus c times t's power to the minus b divided by b minus c power. So we need to differentiate it first, and e to the b minus c times t's power doesn't change when we are differentiating the first part. And then after that, we plus the differentiation of e to the b minus c to the t's power times 1 plus k times e to the b minus c times t's power to the minus b divided by b minus c's power. And as we have differentiated both parts in our second step, we then simplify it, and we can extract out some common factors in the bracket. And as you can see at the end, we have the differentiation of I to be I0 times 1 plus k to the b divided by b minus c's power times 1 plus k times e to the b minus c times t's power to the b divided by b minus c's power times e to the b minus c times t's power times in the bracket minus b times k times e to the b minus c times t's power plus b minus c times 1 plus k times e to the b plus b minus c times t's power divided by 1 plus k times e to the b minus c times t's power. And as we have the simplified version of the differentiation of IT, the question asks us to find an equation that allow us to find the t when the infected population reaches maximum. So according to I prime t, we see that if we want I prime t to become 0, which is a critical point of IT on which the IT reaches its extreme point, according to I prime t, we can see that if we want it to be 0, we need the nominator in the bracket to be 0, which is minus b times k times e to the b minus c times t's power plus b minus c times 1 plus k times e to the b minus c times t's power. We need this part to be 0, and the whole equation will be 0. So we then simplify this equation when one side is t and the other side is the expression of t. So after simplification, as you can see on the end of our sub question 1, we have this the equation that shows t equals ln ln b minus c divided by ck divided by b minus c. So that is the time when the population of infected people reaches its maximum. So then Zeqiu will talk about how to solve the second question.
Yep, that's right. So for the second question, since in question 1 we have already solved the equation that represents the maximum t value, and in question 2 they gave us the exact values for these constants b, c, and k. So we can simply, for the first sub question, we can simply substitute these values into the maximum differentiated equation in question 1. And finally, after calculation, we get 74.98, which is closest to 75 days. And this number of 75 days gives us when the maximum value of infected people reaches. And for sub-question 2, they were asking for the exact number of infected people. So we can just simply substitute the number 75 into the initial equation the question gave us. And which means substituting 75 into the equation, and then we get 6,204. So that's basically the solution of the question.
So the time when the infected population reaches its maximum is 75 days, and the maximum population is 6,204.
That's
so
right.
That's basically our solution for question 3. Thank you.
Thank you.